Oh, I'll make that.
I thought about that last time. Yeah,
I'll take it.
I think
Testing, 1, 2, 3. Testing.
Thanks, Jess. It's great. They weren't that bad. It's just hard to hear.
Testing, 1, 2, 3. Okay, ladies and gentlemen, welcome to the final lecture before what? Spring break. Yes. Congratulations, you've all finished your project 2. You are now done with P1. You're done with P2. The only thing standing between you and graduation is P3. Okay? P3 is a doozy of a project. It is the big project in EECS 494. It takes a little bit less than half the semester, okay? But it is, in I think most students' opinion, it's the best project, okay? I'm really curious on how you're feeling now that Project 2 is finished. You got your kind of first intro to Unity and a bunch, big batch of experience with Unity on Project 1. You learned how to do things. You learned how not to do things. And on P2, you got to kind of start fresh. You got to apply some of the things that you've learned on P1 and in the lectures and work some game design as well. So how did P2 feel? I'm really interested in reading your P2 postmortems, which I'll talk about in just a moment. How did you feel? How'd it go?
I thought it went well. Like I've used it a bit before this class, but I like experimenting with field.
Cool. Very good. Anyone else?
I just wanted more time to actually do level design.
Yeah. There's never enough time, is there? No, never enough time. That's just how it goes with game dev. I think that's usually how it goes with creative works as well. One of the really hard things about creative development processes is that you get to the end of a long creative development process and you're kind of burnt out, right? A lot of the things that make a game appealing or a film appealing, the novel, a book, a painting, is the novelty of it. You haven't seen it before. Right? You might enjoy a game for the first 3 or 4 hours playing it, but you've been working on these games for not 3 or 4 hours. You've been working on these games for tens of hours, 100s of hours, possibly. And so the magic, the mystique, right? The romance of what you're working on is long gone. The honeymoon period is definitely over. And it can be hard to keep going. To finish the game. It can be hard to enjoy the game once you've released it because all you see are the issues, the things you didn't have time for, the mistakes, right? One of the best anecdotes or antidotes for that, one of the best things you can do if you're feeling a bit down about your game dev, down about any creative process, is to hand it to other people, okay? Hand your game, your book, your novel, your image, your painting to someone else, or post it somewhere, like Twitter or whatever it's called. It's X, I think, now. Did they ever fix the tweet issue? Like, what is a post known as now on X? Does anyone know? or Blue Sky or something, or LinkedIn. One of my favorite things to do when I was working on Greek tragedy, in the middle of that nasty development process, ask me about that someday. The only way I was able to kind of keep going with that game was, I would work on some features, be very bored of doing so. And then every few days, I would get a new person to play test the game, and I just watch them play through the game for 2 to 4 hours on Discord. And I'd say, I can't believe you're enjoying the game, right? This boring game. Well, it's not boring to them, okay? They're seeing this stuff for the first time. So you can kind of live vicariously through your players, okay? You can remind yourself that what you're doing really does matter to people. Even if, for you, a lot of the magic and mystique has been lost. So anyway, just keep that in mind the next time you're kind of feeling down or feeling a little bit, in the doldrums, a little bit melancholic about all this effort and time you're putting in. Go make a new build. Go find a friend, say, hey, you got 30 minutes? And then just put it in front of them, okay? And yeah, they're going to discover some issues, but chances are they'll like it a lot more than you do, all right? So anyway, use that if you can. All right, if you look at the schedule here, you finished P2 Gold. Congratulations. It's not an easy project. There's nothing easy in this course. Sometimes I mention that something is easy or straightforward. Whenever I say that, know that that's relative to kind of the situation here, okay? The kind of things that you do, other universities cannot believe how fast you move, all right? And I don't think I could run this course with any other group of students. It just wouldn't work. I'd have to chop things. I'd have to dumb things down a great deal. But you finished Project 2, and so you now have some experience building a game. You now have some experience designing your own game. This was meant to be a prototype, and sometimes game designs just don't work. They just don't work out. On paper, they've got interesting decisions. On paper, everything is well-guided, but it just doesn't work. It just isn't fun, okay? Welcome to creative work. That's just how it is sometimes. But the good news is that now you get to kind of regroup, take a break, okay? Figure out what you care about and what you want to try on P3. If you have had a kind of a tough experience on your P1, okay, now's your chance to form a team that is going to be awesome for you, okay? And you don't have to take that chance. You can just roll the dice and go random. Often that works out pretty well. But over the next week, over the next couple weeks, the main thing you're going to be focused on is the P2 postmortem. The kind of questions I'm asking now, the kind of things I'm bringing up are questions you're going to have to reflect on that P2 postmortem. Remember, right, we don't want anything super fancy here, okay? But we do want you to make a very earnest and honest attempt to dump your brain, dump your thoughts, okay? We actually want to know how you're feeling about P2 and about how things have been going in the class thus far, okay? So make sure that you do that. Not a high-pressure assignment at all. I think the spring break doesn't technically begin until Saturday at noon. So you can easily have this finished before then, and then boom, you get the whole spring break to just chill and relax, and don't think about 494 too much, okay? One thing you do probably want to ruminate on is like, hey, joining that P3 team. If you've got people you know you want to work with, that's awesome, okay? Send a message or an email to them. If you don't know who you want to work with, but you don't want to go random, what you can do is you can go into the Discord server, you can go into that exhibition channel, and go play some of these games, okay? They've all been posted, and you can go find some games that you really resonate with, right? Find some people that you're excited to work with. Find people that love the same genres that you do. If you really want to make a first-person shooter action game for your P3, then go look for people who are into that, okay? Or go ask on Discord. Go find people who are going to be into that, all right? Okay, I'll also say this. one of the most important things you can do as you try and form your P3 team is try and find people who have similar expectations and desires as you. Not just genre, but you want to find people who, hey, if I'm really serious about this project, I want it to be a gleaming, fantastic portfolio piece. I want to win the showcase. I want to go work in the games industry. That's, a very different mentality than, hey, I want to do a good job on this P3 and in the course overall, but, it's not my focus. I've got a lot of other stuff I'm busy with, right? I'm not focusing exclusively on 494. Both of these kinds of people will do wonderfully in this class, okay? You don't need to go crazy in this class, but it can be very difficult if you are a bit more chill and you end up on a team that has a bunch of people who are going crazy, putting just hundreds of hours into a project, okay? That will lead to some consternation if those expectations and desires are not kind of sort of synced up, okay? And so just be careful, all right? Finding the right fit is really important. If you're on a great team, the experience will be so much more than the sum of its parts, okay? You'll have just the best time in the world. If you're on a team that's a bit desynchronized, right, or not a great fit for each other, that can create a really, really poor experience, okay? Much less than the sum of all your parts. The game will come out quite poorly, probably, and you'll have a really bad time doing so. So be careful, okay? One of the reasons that a lot of people take on all of the risks of creating a startup, okay? They give up that big corporate salary. They give up the stability that comes with it. People go and create a risky as heck startup because they will pay anything for the ability to choose who they work with, okay? It's simply that important. If you go to graduate school, one of the most important things is choosing who your advisor is going to be. Who do you best connect with, okay? But after you enter that lab, right, you might be working with people you don't get to choose. If you go and join a big corporate team, it might be a long time before you're a manager or in a leadership role where you get to make decisions about personnel and who you work with, okay? And so that's the situation. And you can go random on P3 with your team. I don't really recommend you do, but you can if you like, all right? It's really worth looking into what people have made, what kind of cool people are out there, and investing in your personnel process, okay? Anyway, but that's just a recommendation. You can do whatever you want. That's the magic of a capstone MDE course, okay? You get to go do and make whatever you want and enjoy the fruits and sorrows of that effort, okay? Okay, does anyone have any questions on any of the rambling I just did? Anyone? Okay, so let's go ahead and take a look at some announcements. Midterm evaluations for the course are, I think they're out. And that's a really, really impactful source of feedback for ideas and how we want to improve the course. It's more important than ever, given that I'm making new courses and my time is so constrained with a lot of things. If things are going wrong in the course, or there's some friction, if an assignment didn't really work out for you, or if there are things you really like about the course and you don't want to them to get changed, I really, really appreciate your providing that feedback and those ideas, okay? So much so that I think you get extra credit at the end of the semester, depending on how many people have done these evals. So if you have any extra time, I really appreciate you filling them out. Remind your teammate, if you can, send them a DM or post it in your group chat, a reminder to do it, and everyone will get more extra credit, okay? If you remember that iterative process chart from earlier in the course, you're going to see it again soon when we talk about playtesting. But you can't really figure out where you want to go with your course or your game or your book or your comic book or your film unless you have that feedback, and you need it continuously. So I really appreciate you letting us know how things are going, okay? All right. The Neuro VR Laboratory is seeking a Unity developer. This is a really exciting development for me because the Neuro VR Laboratory, and in particular Daniel Kortemeyer's work in that lab, is what actually led to the creation of EECS 440, the XR course that uses Unreal Engine and Unity to do XR, VR, and AR. And so Dr. Krishnan is seeking another student developer who has some experience with Unity, right, and VR. If you've only got experience with one of those things, that's fine, right? You can learn how to do VR. I think it won't be a super huge thing or a super huge problem for you in particular. But you can learn more and read more about the NeuroVR Lab. I'll actually show you a quick video as I talk, because I show this in 494, but I don't think I show it no, I show it in 440, but not in 494. This is basically a VR therapy framework in Unity for people who need to rehabilitate themselves. So, for instance, if you have lost control, motor control over some of your limbs, or your sense of balance has been compromised by a medical condition, then a doctor and doctors at Michigan Medicine can prescribe you these mini games, right, to play. And when you do play them, the mini games can be customized, their difficulty can be changed, their feature sets can be changed, and your progress, your improvement over time can be logged and kind of monitored by your medical professional to make sure that you're on track to recover whatever functionality you lost, okay? This is a really, really human and very kind of socially impactful use case for game dev, okay? There are an unlimited number of games for entertainment out there. And while they are socially impactful as a group, us making more games that are just about recreation might not be as impactful than creating something more niche like this, okay? This is not the kind of thing that exists out there in the world. This is very rare, okay? Anyway, yeah, if you're interested in this kind of thing, if you want to go to grad school, Dr. Krishnan can write a letter for you. I can write a letter for you. So boom, right there is 2 out of 3 letters you need for grad school. Okay, and it's going to be looking pretty good for you as far as getting into some grad school institutions. All right. Anyway, just an opportunity. Dr. Krishnan is really, really great. Everyone who's worked with him has told me he's amazing. Keep that in mind. I saw this the other day, and by the other day, I mean 2019, 6 years ago. How time flies, right? I always love to show this because it was a reminder that when you learn game dev techniques and technologies, when you exit 494, okay, maybe you go to work at Blizzard or Tencent or EA or Microsoft Game Studios, okay? But maybe you also choose to go for a little bit more of a stable job, one that pays better, one with a little bit better hours, okay? Those tend to be game-adjacent jobs. What do I mean by game-adjacent? We talk about it quite often, but I don't think I've mentioned it here in this course to all of you during a lecture. A game-adjacent job is a job that uses game dev technologies and techniques, but not for recreational purposes. The NeuroVR Lab is a good example of a really cool game-adjacent gig. And here we have another. Apparently, General Electric, right? Famous game studio General Electric is hiring Unity and Unreal developers what are they doing? Backgrounds, blah, blah, blah. To train robots, so robotics tech, basically, right? They're doing VR stuff, and that's pretty cool. Ford has, if I recall, a design laboratory where a bunch of Unreal Engine engineers create tools to help their designers basically simulate and design new cars, okay? They do so in VR, and they use Unreal Engine a lot, actually, for commercials in the automotive industry. Things like that. I'll tell you more about those gigs, as I see more examples as they come up. But basically, game-adjacent jobs are a really good opportunity to have a high quality of life, to get a job that's going to have a bit less competition. Yes, everyone is applying to work at Blizzard, okay? Not as many game devs know about Ford. Okay, or they're not as interested, right? it's not as romantic to go work at Ford. Well, it's really nice and romantic to have a good work-life balance too, okay? And while the kind of traditional game studio industry has gotten dramatically more stable and now provides much higher quality of life and better pay, it's still going to be a little bit less than what you get at a more general technology company, okay? And so keep those gigs in mind. A lot of people neglect them. And if you do end up getting a gig doing Unreal Engine at Ford, that's going to keep your game dev skills very sharp for that next hiring wave that happens. If you want to jump to a traditional game studio, you very well might be able to, okay? Stardock, actually, in Plymouth, right, Michigan's largest game studio, you know who they hire from most? They actually hire a lot of their engineers, their software engineers, from GM and Ford, okay? Especially the engineers who have been doing game engine-related stuff at those companies. That is a great source of talent, and a lot of people do make that jump. Anyway, I'll go ahead and move on, but just keep that in mind. Game-adjacent gigs are a thing, and especially if you struggle to get that traditional game studio job, you can often find game-like jobs or game-adjacent jobs at surprising places, okay? And have a really, really fun time doing so. All right. Actually, two final things I'll say. I think this is the final lecture before spring break, so maybe there's a little bit less at stake here in this lecture. I'm glad to see so many of you here, though. Today's main mission is going to be to finish up our implementation of a bunch of juice concepts, and then, if we can, get into some post-processing, which is really fun as well. But I want to quickly discuss a topic. You know how in EECS 281, probably my favorite course when I was going through undergrad here, EECS 281, EECS 280, EECS 183, EECS 482, these courses have extremely well-defined and very specific assignment specifications, right? When you do a project in EECS 281, you are told exactly everything that you're going to need to have, okay? You get this input, you must have this output. And you write a program, you've got an auto grader that tells you how well you're doing, okay? And you just go do it, and you know when you've done everything right and you've got the perfect score, okay? I want you to know that that is exceptionally unrealistic, okay? Assignment specifications, right? Specifications are a thing that exists in industry and in academia in the real world. But what's different between an EECS 281 assignment specification and a real-world specification is that the latter is constantly shifting, as if you're trying to build a tower upon a foundation of quicksand, okay? And let me give you a story here. Back in the day, Arbor Interactive, right, which is my company, we made not games for consumers. We would make games for companies. And eventually we made games for the federal government, and that was kind of a nice way to earn some cash. Did you know you can do that? Like, the federal government, municipalities are customers for games. They will pay you money to make games for them. It's kind of surprising, right? One of our first clients, in fact, our first major client that we made a game product for, we got paid several grand to make a small mobile game for a health insurance company. Okay, it's kind of a strange customer, but all right. What they wanted was a mobile game you could play on your iPad, and the design of the game was that it would be like a healthcare clinic, a mental health clinic, and you would go in and you'd be working at this clinic, and you would get famous guests coming in from history, right? Like famous generals, famous figures like Marilyn Monroe. And they would come in, and these personalities from history, right? Historians have kind of done research on them and decided that, they had these, mental challenges that they were struggling with, and you would have to basically interview them and diagnose them, choose what kind of stuff they had going on and how to address it, and stuff like that. So what happened was I made up this game design document. I drew up the art, okay? I drew my own screenshots and basically showed off, here's what the art style is going to be. Here's what the gameplay progression will be. Here are the decisions people will make, okay? And I sent it into the client, into the healthcare company. They said, Austin, this is amazing. Thank you so much. Okay, approved. Stamp of approval. Go for it. I implemented a prototype, okay, of exactly what was in that design document. And then I brought it in about 7 days later, okay? We were having a meeting at like the Panera Bread or something. And I bring it in running on an iPad, and I put it in front of the client, and I kind of watch as his expression goes from like excitement to like, what is this? And he says to me, he's playing the game, he's like, what are these things? And I'm like, this is the game. This is the design document, right? Wait, you read the design document, right? And the client says, well, no, I didn't read it. I didn't read it. I just thought I kind of wanted something different. You want something different, right? What do you mean, right? You signed off on this design document, right? This is what you want. This is what you paid for. This is what I made. Okay, fine. I figured out, okay, what he actually wanted, what the company actually wanted, and then I revised the game to be that, okay? Fortunately, the takeaway here is that because of the rapid iterative design process, basically agile, what you're doing in this course, we were able to find that desynchronization. We were able to figure out what the client actually wanted, okay? And we're able to deliver that because we only lost a week of work. Imagine if I had spent several months working on it without talking with the client, without getting feedback, without doing a play test. And then after months of investment, I'm told this isn't what I wanted, right? Does that lead to lawsuits? Does that lead to, a bankrupt studio, a pissed off client? Okay? Because here's the thing. People will create specifications in real life, in industry, in academia. But sometimes the client doesn't understand what they want. And sometimes they'll write things down only to discover later that what I wrote down worked well on paper, but it's not what I want in practice. Okay? And so please keep all of this in mind. When you enter the real world, you are entering a world of deep ambiguity. Okay? Things will not be perfectly defined. The assignment spec might arrive in the final week of development. Okay? You might be sitting there for months and the client doesn't know what they want. You kind of have to guess. Are you just going to sit there and wait, or are you going to move forward and hope you can use the things you're building now later, right? That's how it goes. That's the situation, okay? You can get through it by using the iterative design process. You can make this work, but it's not easy, and you do have to be careful. So anyway, look forward to that. The last thing I'm going to show you, how many of you do have ideas to go to grad school? If you do go to graduate school, there's a very good chance you'll be involved with AI of some sort, okay? Whether that is research in LLMs or whether that is stuff like machine learning and genetic algorithms. I want to show you a cool 2015 project. This uses a genetic algorithm and some machine learning to try and solve Super Mario Brothers for the NES, okay? Let's take a look. This is Mar.io, and what you can see here is that basically you have this game being downsampled, okay, into a small kind of 2D grid data structure. You can see the enemy here in the middle, right? All of these tiles on this 2D grid are mapped to different locations, different internal nodes within this network. Eventually, these internal nodes up here are mapped to a series of nodes that correspond to the NES controller's inputs. You can see, for instance, that if there is a tile in this top left corner of the screen, then we're immediately going to press the A button, okay? Now, every time Mario dies here and we get reset, this graph is going to change. This graph changes randomly. And so what happens is, after playing, okay, like 10 lives, the game will basically take all the graphs that had the best fitness, all the graphs that got the furthest, and it will use those really fit graphs to create the next generation of graphs, okay? Over time, this kind of creates a series of graphs that are better and better at getting further and further. Now, it takes a while. It takes quite a long time. But toward the end of this video, I think you start to find graphs that are consistently getting Mario to stage 2, which is a pretty big deal, okay? So anyway, kind of a cool thing. And you can imagine if AI was ever, if it ever got very good at playing through games, what? We could have bots playing through games arbitrarily and testing them, right? We could dramatically improve the efficiency and speed of QA, okay, and reduce costs. We could also say this: if you want to make a general intelligence entity, someone who can just exist and reason about the real world, what is a good downsampling? What's a good approximation of the real world? A test bed. Video games. Video games have gravity, they have motion, they have collisions, they have physics, they have rules that in many cases approximate how things work in real life. If you can make an AI that can arbitrarily run through and do well in video games, then you can probably improve that AI to start doing better and better in the real world. Okay, so games are a wonderful test bed for people who want to make real world AI or robotics AI. Okay, so keep that in mind. All right, does anyone have any questions or comments on any of these topics? It is fun to talk about all these things, though they are a bit tangential to the course. So last time, we were building out some juiciness topics, okay, some juiciness technology, and we were using techniques. What techniques do you remember from Monday? Number one, Hooke's law, okay? Hooke's law, the equations that model the behavior of a spring can be used with motion, but they can also be used with anything, really anything that is numeric, for instance, like local scale, all right? And we can get this really nice juicy effect here. Now, currently I'm pressing the space bar, okay, to make this happen. But when you look at this visual effect, you can see that even though we are making the ball kind of get squishy, it's not actually affecting the underlying object, because our second major technique that is going to be super useful to you if you use it is you want to try and separate the visuals of a thing from the thing itself, okay? Why? Because the thing has many rules it has to deal with. It has gameplay mechanics. It has physics it has to deal with, right? And the visuals of a thing also exists in its own complex little world, okay? Where, hey, we have to implement all these fancy visual effects, these juiciness effects, and we don't want the visual effects to conflict and mess with the game's mechanics and physics. And likewise, we don't want the game's mechanics and physics to complicate how we implement the visual effects. In general, in engineering, the more you can keep things separate, okay, you can't always keep things separate, but the more you try and do so, the simpler everything becomes, okay? Modularity, right? It's the principle of modularity. So when you look at this situation, you know, this is not a bad situation, but from last time, we had something that was very annoying, okay? Very annoying, actually, okay? When I pull a water droplet out into my scene, I can no longer see it, okay? I can no longer see it at all. This really stinks, okay? How am I going to design a cool scene if everything is invisible? I might as well get rid of my scene view, all right? Now, everything becomes visible when we run the game unless I forget to drag out the corresponding views, because now I have a bunch of invisible droplets that don't have a view game object in to spawn and track them. So how are we going to deal with this? Well, one way we can deal with this that's fairly elegant is we can use that classic concept of parenting, okay? So we'll say to ourselves, you know what? I never want to have a droplet. I never want to have a droplet that doesn't also have a view. Now, I don't necessarily want the view to stay parented to the droplet forever. But here's what we can do, okay? I'm going to move my droplet view inside of the droplet, And when I begin the game, I want to unparent this droplet view from the droplet itself. So let's go ahead and do that, actually. Yeah, how do we want to do it, though? How do we want to do it? There are a couple of different ways we could do this. Let's go ahead and get some more droplets, by the way. So now when I drag droplets out, it just kind of works, okay? I can go into this prefab and I can say, hey, this droplet view, right, should always follow the droplet that is its parent, okay? Here's what I'm going to do. Follow target. I'm going to add a Boolean, a public Boolean that we can configure. And it's going to be a public Boolean that will allow us to remove our parenting relationship when we start the game. Okay, so public bool, how about let's do clear parent on start. By default, this is going to be false, okay? Because in general, when you're introducing new features to any sort of component, you don't want to do it in a way that's going to affect all of your existing users of that component. This is known as, I think, backward compatibility, okay? And so we'll make sure that we add features in a very careful way so that we don't break things that already exist. So if clear parent on start, which is false to start, we're going to go transform.setParent, set our own parent to null. So what is happening here? Basically, when the game starts, if I currently have a parent, I'm going to get rid of that parent. Okay? So this droplet view will unparent itself from the droplet that it kind of was packaged with, all right? And we can kind of watch that happen. So we've got 3 droplets, okay? Run the game. Everything looking good. I can press space and they all do the cool little bounce, okay? Oh, droplet view does not have this component. Oh, because I didn't turn it on. Okay, let's go to the prefab. So select, double click. I'm going to go to the droplet view. I'm going to click the button, okay? Good, so now we'll actually use the thing. That's another very common bug. You spend all this time building something cool, and then you forget to actually integrate it, okay? So it exists, but you can't use it. I'm going to press space. Everything still works, but look at my hierarchy. My views are now different than my actual droplets, okay? Which is good. You know, it's kind of what we want. Okay. So now we've got all these droplets and things are going well, but I want to step out of this kind of world of cheat codes, okay? Because right now, if you remember our original mission was to have these little droplets bounce and do their juicy little spring effect when they hit the ground. I want to feel that impact, okay? When the droplet hits the ground, I want to see the droplet morph, okay, and bounce. And so we don't have that. I press space to basically force that to happen. So here's what we're going to do. I'm going to go in to hooks scale 4. This is the component that powers that juicy hooks law. And I'm going to get rid of our little cheat codes function, okay? I'm going to get rid of it entirely, all right? Instead, what I'm going to do is I'm going to create a function. Let's call this void bump. And this bump function is going to do what our cheat code used to be doing, okay? So I've got a question for you. Somehow, I need to detect when I've hit the ground. Now, if you look at this droplet right here, okay, this little droplet view, it doesn't really have the components we need to detect touching the ground. It has a mesh render, mesh filter, hook scale 4, follow target 4. What component do you need if you wanted to detect that you've hit something hard? What do you need? Yeah.
Collider.
You need a collider. But if I add a collider onto this view game object, then it's going to start bumping into things. It might collide with the object it's trying to represent, okay? So we're kind of in a jam here, all right? Now, we do have a game object that can detect collisions, okay? It's the droplet itself. So I can go into this prefab for the droplet, and I can say, you know what? I'm going to put a component onto this droplet that detects collisions. I'm going to create a component called has special effects, okay? Or actually, I'm going to go be a little bit more specific. Has visual effects. And I'm going to actually call this has visual effects 2 because I already created this component. This is how I know I'm on track with the lecture and I'm doing things consistently from semester to semester. I keep making the same things. And so, has visual effects 2 will be capable of doing something like on collision enter. Okay? Now, a question is, in on collision enter, I need to somehow communicate the fact that I just bumped into something hard. I need to communicate this fact with the hooks scale 4 component on a different game object, on my view game object. So how can I do this? Now I could write this component so it tries to grab this view game object and then it grabs this component on this game object and then it calls that bump function. But I want things to be a little bit more decoupled than that. Okay, I'm thinking maybe we could do something else. Maybe using a recent technique or design pattern that we talked about. One meant for decoupling things from each other. Yes? An event bus, exactly. Yes, great idea. And you know what? What I'm thinking is we might do something like this. We could go event bus.publish, and then we could have an event. We could have an event called event collision occurred. Okay? How about that? Well, what I'm going to do is I'm going to create this event. I'm going to go, is there a, yeah, I don't know, there's not a function or a class called standard events. So I'm going to go ahead. I'm going to create a C# script. I'm going to call this standard events. Okay. And in this standard events file, I'm going to define my standard event. Okay. Actually, I won't put it in this class. I'll do it here. Public class event collision occurred. Okay. And so what's going to happen is I'm going to go ahead and emit that event to tell the world that a collision did just occur. And in my hooks scale 4 component, I'm actually going to hook up that event. So let's do this. Let's do event bus.subscribe. Which event do you want to subscribe to? I want to get all those collision occurred events. Okay, well, which function do you want to actually use to process that event? Oh, I'm going to make a function. Let's do this. Void on event collision occurred. Okay, event collision occurred E. This is the function I'm going to use to respond to that event. And I'm going to call bump right here. Okay? And so, what do we expect to happen? Well, when we collide with things, when our main game object collides with things, it's going to emit the events, okay? And then our view is going to detect and subscribe to those events so that we can do the visual effect when it occurs, okay? When we need to. So I want you to pay careful attention here because I can no longer press the space bar to make that cool little bumpy effect work. So let's see what happens. Boom. Oh my goodness. Wow, that thing really went crazy, didn't it? I want to get this bump to be less violent because this is just enormous. What is happening here? So here's a cool thing you can do in Unity. Okay, pause. And now what I'm going to do is I'm watching my droplet view. I'm watching its scale, and I'm going to just step the frame forward. Did you know you can do this? You step the frame forward until the thing happens. Boom. Wow. And it goes negative. The scale goes super negative. I'm not entirely sure why it is going so negative. Now, negative 31, 39. Oh my goodness. What on earth? And only now does it come back to Earth, okay, and start getting smaller. Yeah, that's outrageous, okay? That is way, way too violent of a change, okay? So I need to do something to kind of rebalance this, okay? So Hooke's scale 4, yeah, I don't like that at all. Hooke's scale 4, bump power. What does bump power do? Bump power velocity minus equals bump power. Possibly, because it looked different than when I was pressing space. Maybe what's happening is that we're bumping a couple times. So here's a way we can kind of check this. I'm going to go ahead and put debug.log in here, and I'm going to say bump. Okay. Now I'm going to also turn off 2 of my 3 droplets so they won't fall, and I want to see how many of those bump messages show up. Okay. Oh my goodness. And we got 558 of them. Why do we get that many? That's crazy. Why on earth? Probably because the sphere like bounces a bit, but this almost seems like a collision bug in Unity itself. So subscribe to this, putting that out. Okay, bump. Let's do has visual effects on collision enter.
You have the subscriber boundary update loop. So
Oh, do I?
Yeah.
No way. Do I? Good catch. Let's go to Hooke scale 4. Amazing. Amazing. Okay. I'm surprised I didn't catch that. Well done. Okay, so what we really need here is the start function, because we want to subscribe once, please. So what was happening here is that one event was being emitted, and I was just about to put a debug statement into this on collision enter, at which point we would have seen there's only one of this, but it gets called, 500 times. And so anyway, we're subscribing once to this function, so we're only going to run it once. Let's see what happens. Okay. Okay, here we go. And looks good. Looks really good. All right, we're all done, right? Well done. Mission accomplished, team. And I'm going to turn these other ones on, and that looks great. Oh. Wait a second. Something happened. What happened? Yeah.
They all, like one hit, they all.
Yeah, watch what happens here, okay? And I'm actually going to add a couple more balls in just to make it even more obvious. But something is going wrong, okay? Something is going very wrong. So boom, boom, boom. When one ball hits, oh, why are they not falling? What happened to my other balls? They're gone? What? Oh, I duplicated the views. I need to be duplicating the actual droplets themselves. There we go. Okay, there we go. All right. So watch what happens. Every single time a ball hits the ground or anything else, nice, wow, look at that stack, it is going to emit a collision event. But that collision event doesn't have any information on it to say what things collided. And so whenever anything collides with anything else, everything that has subscribed to that event will do that effect. And that's not what we want, okay? We are doing too much bouncing, okay? And this is not looking super good. It doesn't make any physical sense, okay? And so what we can do here, how can we fix this? Well, one way we can fix it is by going in and saying, we're actually going to provide more information inside of this class, okay? This class is actually going to tell us which objects collided, okay? Game object A, public game object B. And I'm also going to say you can't create this class, this data type. You can't instance it without providing both of these pieces of information. So I'm going to create a constructor, okay? Okay. There we go. A equals A, and there we go. Good job, AI. And so now, if I go back and let my compiler do its thing, the compiler is going to point out to me that, hey, you have to go fix this up. You have to provide the list of 2 game objects that collided, which is easy. On collision enter, the first game object that has collided is my own. The second one that has collided with me is in this little collision object that I send through, collision.gameObject. Okay? There we go. And so, it's funny seeing this. The stuff we're using right here are the things that my game engine architecture students are implementing in their own engine. So if you wonder, how does collision work? Like, what causes it to get filled out and sent in to this function? It's like my students in EECS 498 are figuring that out right now and building it. So anyway, okay. So what can we do with this? Well, now every collision object now has more information. So inside of this onEventCollisionOccurred function, we can now check whether E has a certain game object, A, right? So we only want to do our visual effect if the collision object is also the object that we're following. So let's go and grab our follow target for component. Okay. We're going to grab that follow target component and we're going to check, hey, if the colliding object is equal to our target, okay, or the other colliding object is equal to our target, then we want to do the bump. Or another way of thinking about this is if, let's see, yeah. If A is not our target and B is not our target, then we want to just return an early out, okay? And so, let's see what happens. So our hope is that now, boom, boom, boom. Okay, now nothing is doing it. Okay, so what's going on here? So let's go ahead and look at our droplet objects, okay? Our droplet, right, has visual effects, good. It's going to emit stuff, all right? It's going to send stuff through our current game object, also the thing we hit. That's good. This droplet view is going to have a follow target for, oh, this is a transform. So we actually need to do slightly different logic. So let's go to hook scale 4. We're going to go target, let's go target dot game object. There we go. I think this is what we're going to want. So if that object that's colliding is not equal to our target and the other object that's colliding is not equal to our target, then we'll bail, okay? All right. Boink, boink, boink. Nice. All right. Looks good. This is slightly creepy, seeing this like snowman style stack. So what I'll do is I'll just slightly move things over so the physics engine will resolve them properly. Okay? Okay. So you can see that we now have kind of fixed things up. We've gotten things working and we have maintained a lot of stability in our engine, in our game. Development moving forward is going to be easier because we can just think about our objects as normal spheres. We don't have to care about their visuals, okay? What's more, the actual objects that compose our mechanics, right? They don't care about visuals. The visuals don't care about the objects. They just follow them around, okay? And so our situation is stable, you know, kind of sort of clean, and things are decoupled, which means it's going to be a bit easier to introduce new things in the future, okay? And to reason about the things that we already have. So this is good stuff, but when I look at this, I'm not super convinced that these are actually droplets, okay? They don't have the right color, and they don't seem to goop when they move. So what I want to do is I want to go in and I want to build some more stuff, okay? So let's go ahead and create some materials. That's one of the big things that we're missing here. So I'm going to create a water material. Later in the course, I'm actually going to show you how to program a water shader so that you can kind of feel like you're underwater. But let's grab this water material, and I'm going to go in. I'm going to say, well, I kind of want a nice bluish color, okay? So how about something like this, okay? When I go to my droplet, I kind of just drag it on like that, right? It doesn't look like water. It looks kind of like a toy, like the kind of ball you'd see in a ball pit, okay? It's better, but not great. I can go into this droplet, and I can go to Overrides, Apply, and now all of my instances have that material. But I want to go this material, and in particular, I want to change the way that lighting interacts with this material, okay? It's too shiny right now. It looks like a ball. It looks like it's made of plastic. So let's do this. I'm going to go to my material. I'm going to change us away from the standard shader, okay? And I'm going to go to the unlit shader. I'm going to go to the color unlit shader, okay? Now I have something that actually looks quite a bit more 2D than 3D because lighting doesn't affect it at all. It's just the color, okay? It's just the color, right? Now it's still a 3D object despite looking 2D. And when we watch it kind of come down and fall, okay? That looks kind of cool. It has a little bit of an artsy visual style now. But it still doesn't look like it's really moving. It doesn't have a good sense of motion. So what I'm going to do is I'm going to go and I'm going to add a component. I'm going to add the component to the drop view, the droplet view, okay? Let's go into the droplet view's prefab. Why is this gray? That's strange. Why doesn't this have the material? This object, oh, okay, there we go, water material. So I'm going to bring in water material for this one too. Okay, there we go. So what I'm going to do is I'm going to add a component. I'm going to call this one trail render. And if you haven't used this one, how many of you have used the trail render? Okay, the trail render is super, super cool, okay? When I move the object around after it has a trail render, it will leave this trail behind it. And you can configure all sorts of things about that trail, okay? You can configure how long it takes to go away. So let's make a really short duration, okay? And now when I move my trail around, right, when I move my droplet, we're going to get that effect. I actually want it to be even shorter. So 0.05 maybe? Really short. Look at that. That looks really nice. You see how it kind of is square, though? It looks like a cape that's following around my object. Okay? I want it to kind of trail off and get a little bit more thin as it is toward the end of the trail. So right here, I've got this little graph that shows me the width. You can see the width of my trail is always 1. What I'm going to do is I'm going to double click in this graph on the line, and now I can move around and change it. So at the beginning of the trail, it'll be 1 and nice and thick, the same thickness of our object. But toward the end of its lifespan, it will go down to a really thin wisp, okay? And now look at this. You see that? Isn't that cool? Now it actually looks like it could be a beam, a projectile or something. And it looks like a beam because we've got this very bright color palette. We've got this very, very hot pink, right? Now this pink that you're seeing right here, this is the kind of pink that like you almost never see in real life, okay? It's a little bit too potent. You do see lots of pinks in real life, but you never see like this pink. So this pink was chosen because very few game designers will want to put it into their project. This is the pink you see when something has been misconfigured. Okay? Something is missing. This is what it's trying to tell you. Okay? In other game engines, they choose a different color. In the Source engine from Valve, they do something really funny. If you have a missing 3D model, they'll spawn in a 3D model that is very annoying. It's a very annoying red that just says, like, missing. And that's it. Okay? Or no model or something like that. And the objective here is to get your attention so that you, the game designer or developer, will fix it, okay? In any case, if we go down to materials, we can see that indeed there's one material that is null. It is missing. And so let's go ahead and choose a material. We could choose anything, but what I'm going to choose is just the default sprite material, okay? You can see here that now we've got a different color, and we can now go and choose whatever color we want. Now what I want is I actually want to use the same color that we're using for our droplet, okay? So what is that color? Well, I'm going to go back to the material. I yawn up here, and then all of you are going to want to yawn as well. I'm going to go grab the hex code of this blue right here, and now I can go in back to our trail render, and I can actually punch in the color that I want here. Now, one thing that's interesting is that you see, I actually don't have one color, but I have two. And so I actually have just created a beautiful gradient. If I make the time duration here a little bit longer, you can see, right? Look at that. Isn't that awesome? That looks like super good, actually. It doesn't look like rain, but it looks super cool. I want to run my game just to kind of see how this looks. Maybe I'll end up using it one day later, okay? Cool, all right. But I don't want it to be this gradient, okay? I want to have something that is kind of uniform. So I'll just make it all the way through like that. And what I'm also going to do is I think I'm also going to make it a little bit shorter than 1 at the start, okay? So that things look good still when they are getting big and small, all right? Okay, so let's go ahead and run the game and see what happens. Okay, there's a little bit of glitchiness going on. Let me see if we can kind of pinpoint what's happening here. That looks really cool, doesn't it? Like that is indeed a droplet. Okay, so we go and do the effect here. But our trail is kind of glitching a little bit, right? I'm not entirely sure what's causing that. Yeah, like look at that. Okay, so you can see here, basically the trail itself is not resizing and changing its width. It's not changing its width when we go to change our width. And that's a bit of a problem, right? So I'm wondering if maybe, and I usually don't do this in lectures, but if maybe we can fix this, okay? So here's an idea for you. I'm going to experiment and simulate this in the game itself, okay? I'm going to get to a point where it looks really bad, okay? Okay, that looks terrible. You see that? I'm going to find that droplet in particular that looks awful. Look at that. The trail is just not looking good. This width needs to be smaller, okay? So look at this right here. I'm going to go to the trail render, and I'm going to see if I can just kind of bring it down like that. That looks good, right? And I brought it down to something just under 0.5. The width should be 0.42. So one question is, can we write some code to automatically deal with this? Okay, and I think the answer is yes. Let's go into hook scale 4. Okay, hopefully I can figure it out before we run out of time. Let's go ahead and let's grab a reference to that trail render component. I'm going to call it TR. Okay, TR equals get component, trail render, boom, just like that. Now every time we change our local scale, okay, to make that Hooke's law happen, we need to go in, what is that? TR, oh, that was the hex code of my blue color. That was still in my clipboard. Let's go to width here. We have a start width and we have an end width, okay? Now, I think we can use these, but remember, you know, it's kind of an awkward API because they give us start and end, but what if I click many times, right? How do I adjust the nodes in the middle? Well, in any case, what I'm going to do is this. I'm going to, let's see here, go, hey, transform local scale X, okay? Our starting width of our trail should always be the local scale, okay? No matter what. So let's let's see what happens. I don't know if this is going to work. I kind of freestyling it right now. But let's do it, and let's just see if it looks nicer. That does look a bit nicer, okay? But there's still problems. What are the problems here? Okay, boom, boom, boom. What is this issue right here? It looks to me like it needs to be a little bit smaller, okay? If I make this a little bit smaller, does it look better? Okay, let's see here. Let's experiment. Take the width and make it a little bit smaller. Okay, yep. Yeah. So it's like this, but minus 0.2, maybe? If we make it too small, the trail won't match the shape of our tier, of our ball, and that would be a problem. So let's watch it come down now. Ooh, yeah, that does look quite a bit better, all right? Now, it doesn't look perfect still. Often with visual effects like this, you really need to get in there and tweak things, right? Because, you are doing something artistic, so getting it just right is going to be a matter of taste. Anyway, right, we're looking pretty good. Things are working pretty well. A couple things I don't like here, all right? This background is driving me crazy. Okay, this nasty default skybox. If you leave the skybox in your game and anyone who has ever used Unity plays your game, they're going to see this and they're going to think, oh, this is like a 1 week like game jam game. Okay, super low effort, super quickly made, and that's not the case for us, right? And so we got to get rid of that as soon as we can. I'm just going to make it a cool little night scene here. Okay, maybe it's like the Arctic at night. All right, so we'll give it a cold vibe and a watery vibe. Okay, so that's good. Another thing, though, is that I really want to have screen shake. Okay, when my objects hit the ground, I want to take my camera and I want it to kind of sell me on that impact. Okay, so how can we do that? How can we make a screen shake happen? Well, you might say to yourself, well, what is a screen shaking other than the camera kind of being jostled around, right? Imagine that this ball just hit the ground. What if I did this? Whoop. Or I did this, doing. That actually looked kind of good, right? Imagine the ball come down, doing. Okay? But we can do that via code. What's more, when you look at high quality screen shake, usually it's like boing, 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 boing. The position, the local position is disturbed, okay? But then it always kind of comes back and corrects to its natural resting position. What does this remind you of? It's almost like our camera is attached to a three-dimensional what? A spring. Oh my goodness, are you telling me that we can use Hooke's law for something else? Oh my gosh. And that's what we're going to do, okay? So what we're going to do here is we're going to go in, we're going to create a new component. If you think about it, this is not a distributed problem we're solving because we only have one camera most of the time. So this is a centralized problem, so we should have a centralized solution. And so we're going to create a component, a manager component. We're going to call it camera. Actually, let's call this Screen Shake Manager 4. It's the sequel. So Screen Shake Manager 4, this is a component that is going to be responsible for basically moving our camera around. Okay, now what can we do? Well, we can do the same logic as in our Hooke's scale component, but now I'm going to write a function called Hooke's position. Okay. And every frame we're going to call Hooke's position. If we want to do hooks properly, we need to keep track of velocity, okay? So velocity here, since we're moving in 3D space, right, is going to be a vector 3. It's not going to be a float, okay? It's going to be a vector 3. Let's call this velocity, okay? We also need some other parameters, tweakable parameters, okay? By the way, I want to give it a starting value, vector 3.0, so we know what it's going to default to. I want to give it a stiffness constant, so K, but actually I'm going to write this code even better. I'm just going to call this stiffness, okay? And let's go 0.01. Let's create public float bump power. Let's call it 0.1. What other things do we need? Oh, we need dampening factor. Public float dampening factor, 0.99. Okay, let's try that at first. Okay, and now what is the algorithm again? Well, we need to calculate our x, also known as our delta. Okay, and this is going to be a vector 3. Okay, since we're working in 3 positions. Delta is going to be the vector that points from where we are to where we want to go. So let's go our destination. What is our destination going to be? What is our initial position, by the way? The main camera, 0, okay, 0, 3.4, negative 4.74. I'm not going to remember that. Okay, 0, 3.4, negative 0.74. Was that it? 7, 4.74. Okay. Okay, there we go. So this is where we want to be. That's our initial resting state. And this is where we currently are. Okay, so that's our delta. And once we have a delta, we can calculate our acceleration. So acceleration is also going to be a vector 3. It's going to be a delta times our stiffness, okay, kx. I should probably put that on the other side just for aesthetics, okay? Acceleration is the difference in our velocity. So let's take our velocity and alter it by the acceleration. Velocity needs to degrade, so let's multiply it by the dampening factor, and then we need to actually use our velocity. Otherwise, it's just a bunch of variables moving around, okay? And so velocity needs to have an impact on our position in order to create the feedback loop, okay? So our position plus equals velocity, okay? And there we go. Last thing we need is a cheat code, okay, to test it all out. Okay, cheat code, which we're going to run every frame. This is just going to check if we press the space bar. Okay, not escape. Let's go space. Let's go ahead and do a bump. All right. We don't have the bump function, so I'll go ahead and write that really quickly. Void bump. This is going to basically, how do we get us moving around? How do we do that initial screen shake? Well, we need to move our position. So transform.position plus equals, how do we get a random vector? Do any of you know that? This is actually kind of cool. You do unity engine.random.onUnitSphere. This will give you a random point, i.e. a vector 3 on the unit sphere, which is a really good way to just kind of jostle ourselves around. We need to move by bump power, okay? So there we go. And we'll play around with this and we'll get a feel for what feels good, all right? So I'm gonna play maximized at first, then we'll pause it and adjust stuff. Okay, space, space. Ooh, ooh, not bad. Right off the bat, that looks pretty good. I press space and sometimes it takes my camera up, sometimes down, right? It jiggles a little bit and then comes back. Let's go ahead and see if we can tweak this a little bit. Pause. I wanna bump big time, okay? Huge. Like an asteroid just hit outside on the diag, okay? Right? Looks awesome. It's kind of jerky though, so maybe we play with our stiffness and make it go down a little bit. Try that. A little bit less stiff, okay? Maybe we degrade and end this a bit faster, okay? Wow, this is pretty nice, okay? It's ending too quickly now. I don't want that. I want a little bit more, okay? And maybe just a little bit less, okay? Ooh, isn't that nice? If you have an enemy that attacks the player and you take damage, if you really want to sell that damage, right, you know how to make the character flash. You know how to program a sound effect to indicate the damage. But if you look at a lot of action games, Super Smash Brothers, Bayonetta, Devil May Cry, when you get hit or when you hit an enemy really hard, the game will actually pause for a second and then it will do the screen shake. Sometimes your character will even do a little movement like the screen shake as well, right? To just show them getting knocked back. So it really, really sells the damage. In any case, this is pretty good. I'm going to pause here and I'm going to copy all of that data and configuration. I lost it, but now I paste it back in and it's back. Okay, this looks really great, right? But I want this to do a bump, not in relation to some cheat codes. Okay, I want to do the bump in relation to that event coming through. But actually, before we do that, we have a huge problem. Okay? What is the problem here? When I press spacebar, our camera is going to move around, okay? Like this. But what if I want to take this camera and I want to move it to a new location? What if I want the camera to follow the player? What if I want to give a new angle to the action? Well, guess what? Look at what's going to happen when I try and move my camera. Boing. I bring it up here, get in the new shot, doing, doing, right? Wait a second. Our camera now has been like locked in place. This is not what we want, okay? This is not what we want at all. Let's see, camera rig. So when you watch people who are filming, in like a real life show or a film or whatever, you'll find them carrying things like a camera rig, all right? You put the camera into this rig, into this contraption, and it will have an effect on the camera. It allows you to very steadily move the camera around, okay? It allows you to move the camera around, and inside, you'll often have the camera attached to like a bungee cord. So if you need to, the camera can be shaking while you have everything stable, all right? Or alternatively, the camera can remain stable while you're shaking with your imperfect human motor skills, and the result is still extremely smooth. What we need here is a camera rig, and we need to do our math locally within that rig, and that will allow us to move the camera around and rotate it and position it as we want, but while still having effects like screen shake going on. Okay, so here's the technique we can use to do this, and this really is a classic. I'm going to create a new object. I'm going to call this the camera rig, okay? I sometimes call it the camera container. I'm going to put this camera rig, it's way down there. What's it doing down there? I'm going to put it in the same location as my actual camera. Let's go copy the transform, and I'm going to paste that right here. Okay, so now, if you look carefully, you'll see that our camera rig and our main camera are at the same location. Now I can take my main camera and I can parent it underneath the camera rig. So the camera rig is what we're going to move around, okay, and rotate in order to position the camera and make it do cool things. But we have to update our code if we want this to work. Because right now, the way that Screen Shake Manager works is it uses raw world positions that are not affected by that parent. So instead of the world position, the global absolute position, we want to use the local position, okay? So do a quick search for position, okay? Everywhere that it is used, we want to change it to local position, okay? So there we are, okay? Okay, and this value right here is not where we want our camera to always be. We want our main camera to always have a local position of 0, 0, 0. That is its resting state. So I'm actually going to change this to vector 3.0. From algebra, what is 0 minus anything? It's just the negative version of that thing. So I could just get rid of this, actually, and this would also work. But I don't think it looks as good. I don't think it's as readable. So I will bring it back. Okay? The compiler should hopefully just optimize this away anyway. But let's see what happens. Okay? Let's see what happens. So I'm going to play the game. Okay? Boom, 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 boom. Stuff is falling. The camera's shaking. I'm pressing space to shake the camera. Look at that. Okay? Now what I'm going to do is I'm going to move my camera. Okay? Oh, I can't move the main camera inside. Don't do that. But if you want to move this camera, you move the parent, you move the camera rig, and now we're golden. I can press space all I want. I can rotate that camera rig all I want, okay, to get a cool, different view of the action, and I can press space and everything is back to working. Cool. So what do we need to fix up still? Well, first of all, did you notice that when I press spacebar, there's like this jerkiness, right? It snaps too quickly. That's because I'm changing the position. What I really want is I want to alter the velocity, okay? That's what I actually want to do. This will probably be smoother when we watch this footage right here, okay? Oh, I need to actually redo some of the math. So let's do that. Bump power needs to go down. Okay, let's do that. Maybe 0.5. Okay, I actually like the way that looks a lot. Maybe slightly less stiff. I like that a lot. Okay, good, 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 good. Okay, I'm gonna go ahead and copy those values, paste them back in. Okay. And now the final thing we always need to do is we gotta get rid of that cheat code. Okay, we build infrastructure in the exact same way that you build scaffolding around a construction site to help you build things effectively. You create scaffolding in your code base too, all right? So now, if we want to bump, what can we do? Do I need to write a bunch of custom logic in order to make this bump happen when we collide with things? No, what can I do? Bingo, right? That's the beauty of events. We already have these nice collision events floating and flying through our code base. All we have to do is pluck them out of the air to finish our job, right? They're already there. We're just going to pluck them out of the air and use them. So event bus dot subscribe. What are we subscribing to? Event collision occurred, okay? What function are we going to use to respond to that event coming through? I'm going to use this function right here that I just created. This function is simply going to call screen shake manager. I'm going to call bump right here. All right. And yeah, we'll hook up the function and boom, we're done. Right? We don't have to worry about anything outside of this code base. One of the coolest things about this as well is that it allows team members to communicate without having to look at each other's code. The only thing my teammate has to tell me is, oh, hey, Austin, by the way, there's this thing called event collision occurred now. It's flying through the event bus whenever things like bump into each other. So, just, grab that if it's useful, okay? It's a very common pattern when you're developing games on a team that you want to add some new feature to the game. Well, it turns out there are already hundreds of events that your teammates have created. You just have to figure out which one you want to use and respond to. You don't really have to talk to them too much. You don't have to look at any of their stinky code, okay? You can just rock and roll. Okay, let's see what happens. I'm going to play the game. Here it goes. Boom, boom, boom. Oh my goodness. The impact is much more easily felt. Okay, and so these now feel very, very, very heavy. Okay, you could add additional information to these events. For instance, one thing we might want to care about is in what direction did the collision occur? Because if the ball comes down and hits the ground like this, we probably want to bump the camera downward, okay, and not in a random direction. Okay. Ball hits the ground and our camera goes upward, that doesn't really make sense. But I'll leave that as an exercise for you if you want to do this later. A reminder, I think all of this code is available on the agenda. So if you want to grab some of this logic or play around with it, you can go for it. What I want to do right now is I want to take our 5-minute break, okay? And then I want to come back and I want to get into a really fun topic, particles. Okay, we're going to implement some particles together. We're going to make this scene feel much colder. Okay, so see you then.
I had an issue with my project.
Yeah.
So basically, I I don't know what happened. I tried saving it, and then I hit like don't save because I don't know what happened. And the project closed.
Yeah.
And then I tried to open it, and it said it's not valid.
Oh.
And then I removed it from the list.
Can you go into that folder?
Yeah, I'm here. The project is eating for two. It's
Yeah, go
right
into. Yeah, eating for two isn't anywhere on here. Oh, your assets folder is gone.
okay. I have the
Yeah.
build made, so
Your assets folder is your entire project. So
okay.
what
got
you
it.
should probably do is you should go back to version control. Control Z. Can you? Yeah. So a valid Unity project must have an assets folder. It doesn't need to have some of these other things, but the assets folder is where everything is. So I'm not sure how that got deleted.
I have it.
Possibly got moved. Accidentally moved to some other place.
Should I just like copy it?
Yeah. Copy it back into the folder, and it will be valid again.
Okay, there's just a warning now. Restrict editor business efficiency. Okay, awesome. Thank you.
Okay, you're welcome. Particles can make your game vibrant, full of motion, beautiful, Particles are fast. They're usually programmed in a very data-oriented, efficient way. The big new assignment that Game Engine Architecture course is getting this semester is the final assignment, which is basically creating your own particle system and re-implementing what I'm about to show you here. What I want to do is I want to create some particles. How do we do that? Okay, this is kind of the Arctic after dark, so I want some nice snowy particles coming down. Okay, I want to go in. I'm going to go to Effects. I'm going to go to Particle System, and nothing happens. But if you look in the scene view, you can actually see that the particle system is spawned up here, and it looks kind of weird, right? You can see it's generating these fuzzy little particles, and it's doing so in this cone shape. It's also sending them straight up. Like whenever I think of particles, I think of rain, right? So I'm not sure why Unity created these defaults, right? Have you ever seen this in real life? Have you ever wanted to make this? This is like your sprinkler system sprung a leak, maybe, and now just sending particles up to the air in your yard. So this is another case of Unity having completely trash defaults that they just refuse to fix or change. But in any case, we have this particle system, and it is a game object, but what makes it a particle system is that it has the particle system component, okay? And this component is an absolute monster. When you open it up, it looks different than most other components because it has all these categories you can open up and an endless array of features. It is a bit blinding, actually, how many things it can do. But right now, there are a few key things that we want to fix here, because right now, this just doesn't look like snow falling. We can improve the situation by doing this and rotating our object like so. Let's go like 90. Yeah, there we go. And now, if we go into our game view, we can actually see, yeah, right? You know, this is like the itch.io grade, like beginner snow particle system. Okay, it doesn't look very good, but that's okay. You're releasing a game on itch.io. It's the thought that counts, right? In this course, no, we actually do care. And so, how can we make this better? Well, first of all, I don't really like this shape, this cone shape, okay? I want to have something a little bit more uniform. I'm going to go to shape down here. The shape category is set to cone. I want something like a box. This looks more like a line, but in reality, it's just a very small box. Each of our particles will spawn randomly somewhere in this box. And so we can make the box a bit wider, like this, for instance. Okay? We can make the box a bit deeper. I don't really want to make it taller. Okay? We can then take this particle system and we can kind of give it this kind of sideways, this angled vibe. And now it feels like we actually have kind of a wind situation here. Okay? It still doesn't look that great, and we're going to have to experiment with it. One thing you might say is there aren't enough particles. This feels like a very kind of a dreary day, a very slow snowfall. So I can go to emission right here, and it says that it's currently generating 10 particles over time. I think 10 per second. I'm going to change this to 100, and it's immediately a deeper snowfall. I'm going to change it to 1,000. Okay? Now look at this. You see how all the particles come in this kind of sandwich, and then they all despawn, and then another wave comes, right? That's because we have a maximum number of particles allowed right here, and I'm going to punch that up, okay? Now we have just this flurry coming down, okay? That's pretty cool. That's pretty cool. What if I wanted this to be a different color, okay? What about gray? Now it's like volcanic ash. All right, that's coming down. But there's a bit of a problem with this, okay? You see how the particles are just kind of going through the ground? That doesn't look very good, does it? Okay? Does not look super good. So I'm going to go down to this category right here called collision. I'm going to turn it on, and it's not working until you switch the type from planes to world. Now, can you see what's happening? We've got particles that are actually being launched back up into the sky because they are hitting the ground, our snow, and they're bouncing. So last time I checked, that's not usually what happens. I'm going to change to a lighter gray, okay? This isn't usually what happens, all right? And so what I want to do is I want to go into our collision category. I'm going to go to bounce, set it to 0, okay? Now, the particles are hitting the ground and slipping off of it. They're keeping their xz plane velocity, and so they're doing really weird things. I don't want that. I want to dampen the motion of my particles. So now I set the damping factor to 1, and now my particles just kind of stick on the ground. That's a lot more reasonable, okay? I'll also say I don't like how fuzzy my particles look, right? My particles are using this kind of default fuzzy look, and I'm not a big fan. I'm going to go down to render, and I'm going to change the default material to sprites default. And look, we've got this pixelated snow that's coming down. I'm actually going to make this white right here so that it looks a little bit more like snow. I'm going to reduce the amount of particles that we are emitting down to 100, okay? All right, I'm also going to change their size because these are way too chunky, okay? Way too big. So let's make the starting size like 0.25. Ooh, that looks really nice. I'm going to go and make our ground. Let's go ahead and just create a new material here. Oops, that is not, oh, that isn't new material. I'm going to make our ground a slightly different colored so that it stands out. The particles look a bit better. Maybe I'll make this like a cool blue as if we're on a glacier or something like that. Ooh, that's kind of cool. Okay, some ice, nice. Okay. When I run the game, things are going to look kind of cool, but it's not going to look perfect. I'm going to turn off my spawner so we can just enjoy the particles for a moment. Okay, prefab spawner. I built this during the break. It just spawns in an infinite number of droplets for us. Now, these are the ones that just automatically fall. So I'm going to get rid of these. There we go. So something you'll notice is that the particles don't show up right away, okay? And that's kind of annoying. It doesn't look very realistic. So what I want is I want to take these particles and I want to pre-warm them. If you click pre-warm, what's going to happen is the moment the game begins, the particle system will have already populated a bunch of particles and put them in their place so that you don't have that weird, awkward delay as everything gets rolling, okay? We have another issue here. These particles, they land on my glacier, but, and they stick there, and that looks great. But then after a few moments, what happens to them? They pop. They kind of despawn. They vanish. That's not what we want, is it? It just looks really cheap. What does snow do? Well, snow melts, right? So why don't we create a melting effect, all right? I'm going to go to the particle system, and I'm going to go find a category. It's very powerful. It's called size over lifetime. I'm going to click the box to turn it on. I'm going to click on this graph, and I'm going to say, hey, you're going to be 100% of your size, okay, at the beginning. But toward the end, actually, you're going to start to shrink, okay, like this. So now, hopefully, we won't see the particles pop away. We will see them slowly land and start melting. Nice. This looks really nice, right? Now, this isn't usually the way that you see snow fall. If there's a very consistent wind or no wind, you'll see snow fall in this very straight down linear path. But usually there's a sense of wind, right? And so some particles will be floating a little bit this way, some that way. They'll all generally be heading in the same direction, but with this noise that's applied to them. So what I want is I want to add some noise. There's this noise category that I can turn on. And if I do and click play, look at that. Wow. Oh, goodness, right? That is nice. If you make this noise just really, really high in magnitude, you'll get an effect that looks a lot like confetti. I think this is a little bit too potent, a little bit too strong for representing snow. So what I'm going to do is I'm going to go to a noise, and I'm going to make the strength half of what it recently was, okay? Okay, right? And now it looks like a pleasant snowfall. Like this, I think this looks fantastic, okay? Now, There's another kind of thing that you can do with particle systems, okay? Sometimes you want ambient particle systems like this one, creating a snowfall or some rain or something like that. But in many cases, in fact, probably more often, what you want to do is you want the ability to burst a bunch of particles at a certain location. For instance, if your character takes damage, you might want to spawn a bunch of particles, red ones maybe, okay? Or, you know, ones representing sweat or whatever, or grease if you're a robot. You want to send it flying away, right, to show a collision. If a bullet or projectile in your game hits a wall, you might want to have a spark appear on that wall to sell the impact of that collision. So what I want to do is I want to create a particle system that can do a burst, okay? And let's go ahead and create a new one. So particle system, go to effects, particle system. I'm going to call this earlier particle system the snow particles. And I'm going to call this one, let's call this a spark particles, okay? By default, it starts like this, no surprise, the upside down cone, okay, makes no sense at all. I want to not have a cone, I want to have a shape that is a sphere. And I want the sphere to be very small, okay? I'm going to make the radius like 0.1. I want these particles to be much smaller as well. So I'm going to go to the start size and make it 0.1. And I'm also going to go to the render and get rid of that nasty default. Let's go back to these kind of chunky retro pixels. Looks good. I don't want, let me see. I don't want this linear motion. It just doesn't look good, okay? So I'm going to give these particles gravity, and to distinguish them, I'm also going to make them red, okay? Now what I want to do, actually, let's go ahead and stop those particles. I want this particle system. I want these to have a sense of gravity. So I'm going to go gravity modifier is 1. Now, if you look, it's actually like a fountain. Okay, all the particles are falling down to the ground. I don't like how these particles are being emitted. Okay, it's just this continuous stream of particles, but I want to burst. When the bullet hits the wall, a bunch of sparks are created and things go flying. Okay, and so let's go not rate over time, 0 rate over time. I'm going to click plus on the bursts right here and look at that. Isn't that nice? Watch carefully. Boom, like that. I don't like how the particles are going through the ground, so I'm going to go to collision, turn those on, switch the mode to world, and now the particles we burst out, right, are going to bounce like that. Super, super cool. I can raise it up so we can see particles going down. We can see the spherical shape of the burst. Super, super nice. I'm going to make the particles much larger in count. So this will be a huge burst. Look at that. Wow. I like the red color here, but if you look at a spark, what happens usually is that the spark is usually kind of super red hot, but then it fades out. It loses that red tint as it loses its heat. It becomes more grayish. So I want to start with a red color, but I want my color to change over my particle's lifetime. So I'm going to click on Color Over Lifetime category, enable that. I want my initial color to be that nice red, but then I want it to kind of fade to white. Now we won't see it because the starting color is white. I need to make this white right here. And then as the particles, right, as they get toward the end of their life, they turn white. Our big problem is that our particles live too long. So maybe we only want it to live for just a brief moment. Yeah, why is this? I wonder why they're still living for a very long time. That's strange. Why is it doing that? Looping, okay, pre-warm, emission, probability, count. I feel like something changed in the settings here. Yeah, why is it not...
I think you change start life.
Oh, yeah, not duration. It's not duration that we care about. Yeah, it is... there we go. It is start lifetime. You're right. Thank you. So 0.5, how about? Yeah, so that's not quite long enough. Let's make it a little bit longer, like 1 second. Okay? Here's another thing that I want to do. I want our starting color to be a random color. Interesting. What's that going to be like? Well, that's not working. Random between two colors. Let's go white and red. How about that? I feel like it's not really doing it for us. Let's do this. Not color over lifetime. Oh yeah, there we go. Let's make these shrink over their lifetime. So size over lifetime, going to start being very big, and then we're going to go small and fade out. Okay, that looks kind of good. Yeah, I kind of like that. Restart, right? Yeah, that looks kind of nice. Okay. So this is pretty cool, okay? Pretty cool stuff. Now, one question is, how can we control where we burst these particles at? What I'm going to do is I'm going to create something called the Particle Manager 2, okay? Particle Manager 2. What we're going to do here to burst particles wherever we want is we're going to move this object. We're going to move this game object to a certain location, and then we're going to tell our particle system to play. A moment later, we'll tell it to stop playing. Otherwise, it will accidentally keep spawning particles at that location. So let's do this particle system. Let's call this PS. In the start function, I'm going to go PS equals get component particle system. Okay. What we can do here is we can, let's do this. Let's create a coroutine, enumerator. Let's call this play particles at position. This will, we'll send in a position, okay? And what we'll do is we'll take our PS, we'll make sure it's stopped. We'll then tell it to play, okay? We need to move ourselves to that position, by the way. So transform.position equals pose, okay? And now we're going to run it for just a little bit, return null, play stuff for just a little bit, a couple frames, we'll delay, and then we'll do ps.stop, okay? To stop the particle system. All right, cool. Let's see how this looks. In order to know where we want to spawn it, what we can do is we can go, subscribe, event bus. .subscribe. What do we want to subscribe to? That useful collision event. Okay. What function do we want to use? Okay, to trigger it. Let's go void on KE. Yep, good. Okay, this is the function that we're going to use to deal with these events coming through. And every time one of these comes through, we're going to go start a coroutine, this coroutine, and we want to make, here's the thing. We don't know where the collisions are actually happening. So let's do this. Public vector3 location or position, okay? We're also going to require people who emit this event to also provide the position. Go position equals pose, okay? We'll go to the reference here, new, yep, there we go. And then let's do collision dot contacts dot point, okay? This is the location we are colliding, and this is the actual position, okay? So let's go ahead and see what happens. We can go e.position now to try and tell our particle manager to do a burst there. I'm going to go ahead and tell it also to stop by default. So we don't want to immediately spawn some particles when we begin the game. And let's see what happens. I wrote this super fast because we're almost out of time. But yeah, I'm curious whether it's going to work or not. Okay, so oh yeah, we don't have any we don't have any things spawning. So let's spawn some droplets. Let's see what happens. Boom. Ooh, is that cool or what? Okay, very good. Now, one interesting issue here is you see how the particles spawn, but then if something else lands, okay, so particles spawn, if something else lands, the particle system moves around and the particles themselves will get warped around. It looks kind of glitchy, right? Well, here's how to fix that. If you look at these particles right now, these particles are all parented to our game object. So if our game object moves, then the particles will go with it. what we really want here is for our particle systems to be simulating in not local space, but in world space, which we just did. Now, when I move my game object around, the particles maintain their previous positions, okay? So that's a really good change, and it should make our particle manager and all those cool sparks look way better, okay? So here we go. Boom, 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 boom. Oh my goodness. That looks pretty cool, right? And the last thing I think I'm going to do is, because these are water droplets, right? Because these are water droplets, I don't want this, I don't want this nasty, these red colored particles coming out. These aren't gunshots into cement or concrete, right? These should be water droplets that are scattering everywhere. So I'm going to take this red and I'm going to say, now you're going to make blue go flying everywhere. So watch this. Boom. That's pretty cool, huh? I like that a lot. This entire scene is feeling more impactful. It's feeling a bit colder. It's dynamic. There's a lot of motion here. What we're going to do when we come back from spring break is we're going to first get Project 3 rolling. I'm going to show you what a good Project 3 looks like. We're going to talk about a lot of great things like theming, which is very important for you to decide on your team. But we're also going to show you how to use post-processing graphical effects to, for instance, make this scene look even colder with techniques such as bloom, with techniques such as vignettes toward the edge of the screen. Okay? So please look forward to that. And everyone, you deserve a wonderful break. I hope you'll relax. I hope you'll take it easy. Okay? Don't forget about your postmortem, because that's a bunch of easy points you'll lose if you do forget. And also think about your team, all right? But yeah, knock those things out in the next few days before the vacation starts, and relax a bit, okay? Maybe even play some games recreationally for once, all right? I'll see you all later. Take care. Everyone online, I hope you enjoyed the nice particles, and have a great break, okay? I'll see you later. Bye-bye.